may be classified as energy and power signal. But in all cases, we can define this signal in such way. Later we will see in detail for that chapter. But first you should know about an energy signal and a power signal. That means when a signal is called a power signal and when it is called an energy signal. So first we will call about energy signal. The energy signal is one which has finite energy and zero average power. So the energy signal has two properties. One is the energy signal should be finite in value or in nature, and its average power is zero. Hence, a signal xt is an energy signal if it has an energy which is denoted by E, has finite value and it has a average power which is zero. For example, or it means a signal which is a energy signal. That means if xt is an energy signal, its power must be, average power must be zero. So it is the property of energy signal. So what is the property of power signal? The power signal is one which has, so power signal is one which has infinite energy but have a finite average power. So power signal also have the property, but just it is opposite to energy signal. For example, if xt is a power signal, then its average power which is denoted as P have a finite value and its energy which is denoted by E is always 0. So these two properties will be shown for an energy signal. The energy should be infinite, not it is 0, it is infinite. So these two properties will be shown for a energy signal and a power signal. However, if the signal does not satisfy any of the above two conditions, then it is neither an energy signal nor a power signal. That means if suppose xt is a signal which does not have any two property, that means this property is not shown in that signal, or this property is also, this is E is equal to, for this signal E is infinite and P is equal to finite. So if this property is not seen for a signal, then the signal is neither power nor energy signal. That means for a such type of signal, E will be not be a finite value, and P is not equal to 0. If such a signal, these two properties seen, that means this signal is neither power signal nor energy signal. Now we define an energy signal first, then a power signal. So, first we define energy signal. The energy of a signal is calculated by the formula which is written here. I'm writing here. If xt is a signal, then its energy will be represented by minus infinity to infinity equals to mod of xt square dt, where xt is the signal. So this is the expression for a energy signal. The mod value is considered here for, that means here it is a mod value. The mod value is considered here for the signal nature. That means if the signal is complex valued, then only we can define this mod value. That means the minus term will be deducted then. And if it is true signal or if it is a real signal, then the expression becomes minus infinity to infinity xt square or x square t, or it should be a x square t. X square t if it is a real value signal or a real signal. For a composite signal, this formula is true, and for a real signal, this formula is satisfied. Now, for a signal, energy will be finite. If the signal has finite duration or t should not tends to infinity. Finite duration means its time t does not tends to infinity. And it has an amplitude either constant or tends to 0. That means the signal amplitude must be either a constant value. Signal amplitude is represented by A. So if xt is a energy signal, then its amplitude either it is a constant value or it should be tends to 0. Now we can show here the format of a energy signal. This is t, suppose this is minus t. It is the time duration of the signal, and the signal represented by xt. It means the signal is valid from minus t to t time interval, where the total time is represented by t, small t, and the signal is existed from only minus t, capital T to small t. So in this case you can see the time is constant, that is it not tends to infinity, and the amplitude is also a constant value. Suppose it is A, the value is constant. So in this case, so as these two condition is satisfied, that means first condition is its amplitude is constant and t or time should not tends to infinity. Tends to infinity. So these two condition is satisfied here, hence it is a energy signal. Another type of energy signal is like as you can see, it is a signal itself. The y axis represented by signal itself and the x axis represented by t, where t should tends to infinity. It is minus infinity up to and it is plus infinity. And signal exists, it has a constant value, suppose it is a, and the signal time of the existence of the signal tends to infinity. That means from the positive side, the signal is existed up to minus infinity time. See that this extent of this or the tail of the signal does not touch the x axis. Therefore, it means the signal is continually going with respect to time. Similarly, for the minus or the negative axis, it is also same condition is applied. Therefore, this condition or this signal is existed from minus infinity to infinity. So, if the signal has an infinite time duration, that means this signal is infinite time duration and its amplitude becomes 0 as t tends to infinity. That means you can see here that amplitude is decreasing, and when the time becomes infinity, the amplitude of the signal becomes 0. It would shown from this figure, it would represent that when the amplitude of this signal is it is decreasing, and when it is reaches to minus infinity or plus infinity, the amplitude will become 0. So there is another condition for an energy signal. Amplitude is constant again for a particular time interval, for a, or you can see that constant is not so easy. Amplitude is tends to 0, or we can say here amplitude tends to 0 when t tends to infinity. T tends to infinity. When these two conditions is satisfied, then only we can say it is also a energy signal. So here these two type of energy signal we can see here. From this we can easily say that almost all the practical non-periodic signal which are defined over finite time or all time limited signals are energy signal. So in our last class we have discussed that what is a periodic signal and what is a non-periodic signal. So for a non-periodic, you can remember or you can recall that for a non-periodic signal, the signal is not periodic. That means it has a particular time duration. It exists for a particular time duration and then it is off. So for such type of signal, all the practical such type of signals are the existence or the example of energy signal. There is some exception, but in all cases, almost cases, all the non-periodic signals are the example of energy signal. So we conclude that there is 3 characteristics are considered for a energy signal. So energy signal characteristics. Number 1, for an energy signal, the energy E will be finite and it is non-zero value. For a second one, if the energy of a signal becomes infinite, then it should not consider as an energy signal. And third, the average power P of an energy signal is 0. So these three characteristics will be observed for our energy signal. Again, I am repeating these three characteristics. For our energy signal, the energy E represented as E will be finite and it is a non-zero value. Second one, if the energy of a signal becomes infinite, then it should not consider as an energy signal. And third one will be the average power P of an energy signal is 0. So now I am ending here. In our next class, I will be talking about power signal. Thank you.